You know the feeling, right? You're running late, you pull out your phone to call a ride, and whoa, the price is suddenly way higher than you expected. Well, that's not a glitch. It's called dynamic pricing. And today, we're going to dive into the really fascinating AI that's behind that sudden price jump.
It might feel totally random, right? But it's anything but. Behind that number on your screen is an intelligent system making millions, literally millions, of calculations every single minute, all across the city. So let's pull back the curtain and see exactly how this thing works.
Okay, so for a ride-hailing company, managing a city's transportation, it's like trying to solve a massive, constantly changing jigsaw puzzle. And right at the very heart of that puzzle is this incredibly delicate balancing act.
And this balancing act? Well, it boils down to two super unpredictable forces. On one side, you've got us, the riders. Our demand can spike out of nowhere, right after a concert lets out, or when there's a sudden downpour, or just the classic morning rush hour. And on the other side, you have the drivers, and their availability is just as unpredictable. So trying to match these two in real time, that's the absolute core of the challenge.
So you can probably see why a simple, one-size-fits-all price would just fail instantly. You can't use manual rules. They're way too slow, too clumsy to react to things like live traffic or the weather changing on a dime or all the little events that make a city, well, a city. The problem is just way too complex for simple rules. It needs a much, much smarter approach.
And that smarter approach, you guessed it, is a pretty sophisticated form of artificial intelligence. This is the moment we shift away from those simple, rigid rules and move to a system that can actually learn and adapt to the beautiful chaos of a modern city.
Now, at the heart of all this is a technology called reinforcement learning, or RL for short. The easiest way to wrap your head around it is to think about teaching a dog a new trick, right? You don't write out a long instruction manual for it, you give it a treat when it gets it right. Well, RL works in a really similar way. The AI tries something, like setting a price, sees what happens in the real world, and then adapts its strategy based on whether the outcome was good or bad. It's constantly learning and improving pretty much all on its own.
So the big question is, how does this learning actually happen? Because this isn't just some abstract theory. This AI is getting smarter with every single ride happening out there in the city.
It all comes down to this really simple but incredibly powerful feedback loop. Okay, step 1, the AI sets a price. Step 2, it watches and analyzes what happens. Did a rider get picked up quickly? Was the fare accepted, or did people say, no way? Then, based on that result, the AI gets either positive or negative feedback. You can think of it as a reward or a penalty. And here's the crucial part. It uses that feedback to make a smarter decision the very next time.
So what's the AI actually trying to do here? What's the end goal? Well, it gets rewarded for good things, like making sure wait times are short for everybody. But it gets penalized for bad outcomes, like setting a price so high that tons of people cancel, or so low that there just aren't enough drivers to go around. And through millions of these tiny little adjustments, it's always learning, always trying to find that perfect sweet spot, that perfect balance.
And look, this isn't just about numbers on a screen or algorithms in a server room. This constant learning cycle has a direct, real-world impact on the experience for both you, the rider, and the drivers out there on the street.
Ultimately, the end goal here is to make the whole system work better for everyone. So when the AI gets it right, we get picked up faster. Drivers get more stable earnings because the system is actually guiding them to where the demand is. The entire network just becomes more efficient, matching the right driver with the right rider at the right price.
Here is a perfect real-world example of this in action. Think about a traffic jam. The AI doesn't just blindly jack up the prices to the max, it has learned over time that a moderate price increase is actually the sweet spot. It's just enough of an incentive to attract more drivers into that high-demand zone, which in the end helps clear out all the pending requests and gets everyone moving again. Pretty smart, huh?
But maybe the most powerful part of this whole system is that it never, ever stops. This isn't some piece of software that you install once and then just leave alone. In a very real sense, it's alive. Think about it. With every single ride you take, with every fare that gets calculated, the AI is gathering more data, learning a little more, and refining its strategy. The system that's running the network today is smarter than the one from yesterday, and the one running tomorrow will be even smarter. It's this constant, never-ending cycle of improvement.
So the next time you open that app and see the price surge, you'll know it's not just some random number. It's the result of a learning machine that's solving an unbelievably complex puzzle, right there in real time. And that leads to a final, much bigger question.
If this kind of AI can actually manage the chaos of an entire city's transportation network, what other massive challenges could it solve next?